A very good morning to all of you. As my title says, the hydraulic oil is like the lifeblood of the equipment. I have just shown as a summary the importance the blood plays in the welfare and well-being of the human being as compared to the oil in the off-highway equipment. You can just have an analogy like the heart, human heart, the artery system, the veins, the kidney, they can be compared to the hydraulic circuit. The hydraulic systems in the modern world are getting very, very compact. And most of you, the OEMs in the audience, must be knowing that, just showing here that modern pump, I'm told, can fit into a coffee tumbler, the latest piston pump. Just another example, if you compare with the technology of 1980s versus the technology what we have today, the hydraulic systems are getting very compact. The system, some sizes of the oil are getting reduced. The power of the equipment is increasing day by day. So all this, along with the increased pressure of the hydraulic system, is putting more and more stress on the hydraulic oil used in the systems. So what is this hydraulic oil? Well, this hydraulic oil is a lubricant. Just like you have tea or coffee in the morning by mixing milk and water, the hydraulic oil is made by adding an additive to the base oil. The base oil can be compared to the milk and water, which constitutes about 90% of the hydraulic fluid. So what goes into the hydraulic oil? Inside the hydraulic oil, you have the base oil, which I said which constitutes about 90%. And then the most important component of the hydraulic oil is the anti-wear additive. The most common anti-wear additive used in more than 90% of hydraulic fluids in India today is the zinc-based additive. I've just shown a diagram over there. You can see that this is the zinc, means ZDDP molecule, how it interacts with the surface, and it provides the protection to the hydraulic pumps. Then you have the antioxidant, the anti-corrosion, the defoamer, which prevents foam, and the demulsifier. This is what goes into making the hydraulic oil. The hydraulic oil standards are evolving basis the international standards. In India, we have got the Indian standard IS 10522, which is the basic standard or sets the basic platform for the anti-wear hydraulic oil, which is IS 10522. Then a step above that is the German standard, DIN 51524 Part 2, which most people refer to in the market as a HLP oil, or the high pressure oil. And one level above is you have got OEM specs like Denison Parker HF0. You also have got the Eaton standard. And nowadays, over the last 4 years, people are speaking about the Bosch Rexroth new standard RE 90235, which features a high-speed pump and high pressures of over 500 bars. Then you have got other specs also, like the Japanese OEMs have got this JACMA specs. Some of them, they prefer zinc-free, ashless technology. There are some OEMs in Europe, like Boclane, who are totally opposite. They want high zinc fluid. Then you have got OEMs like CAT who say that the oil has to keep the water in emulsion rather than separate water. So you have got a separate specification for that. Certain German OEMs have got requirement for high extreme pressure load, what is known as fluids having high Brugger value. So that's into a separate category. Then there is a category of biodegradable, environment-friendly fluids. If it's made from a little ester. It's a biodegradable fluid you can make. And most of these ester fluids are also fire resistant, so they give you a safety factor also. So these are the types of pumps used in the market today, and the relative requirement or impact of the anti-wear additive. And then there is also the requirement of filtration, which I'll just come to. You have the gear pump, vane pump, and the piston pump. The piston pump operates at high pressure. You have also got hybrid pumps, which combine a vane pump and a piston pump. This is the picture of the rig of the Denison Parker hybrid pump test, which is also one of the severe category tests, which features a vane pump and a piston pump, which operates for 50% of time in dry condition, and 50% of time there is addition of water in the test to check the filterability and the durability of the parts and components. I've also shown a graph of another OEM, that is the Eaton 35 VQ25 test, which also measures the wear under different test conditions. So as I was saying, this is the Bosch Rexroth pump test, axial piston pump test, which is a really severe test. People say it's the most severe test as on date. This test has a pump which touches the peak pressure of 500 bar and a max RPM of 4,000 with temperatures touching 100 degrees centigrade. So you can see the oils which pass the test, you can see down below, they have got low amount of wear, low amount of tarnish, whereas oils which are not meeting the requirement, you can clearly see it is a clear differentiation is there of wear marks, scoring, and tarnish formation. In this context, I would say around 3 years back, our company, HPCL, was the first company to obtain the approval from Bosch Rexroth in India. Another case, just like the human blood, I said, the most common cause of hydraulic system failure is dirt. Shown out here, dirt constitutes one of the major causes of the failure in the hydraulic system. And I'm showing you a system over here, the actual photograph of a customer operating in a coal mine. The filter has got plugged. So I would again like to compare to the human body. When the oil gets contaminated, you have to go for filtration. In the case of a human being also, when your kidney stops working, you have to go in for a dialysis. So this is what the customer can go if there is heavy contamination in the bean's hydraulic oil. And one of the most important parameters to check the contamination is the particulate count, which is measured by the NAS standard, National Aerospace Standard. You also have got equivalent ISO standard, ISO 4406. So it measures the amount of particles, size, number, the count is there, size is there. And then there is equipment which you can say how clean or how dirty the oil is. NAS 12 oils are considered to be dirty. People who go for super clean oils prefer NAS 6 or NAS 5. Just an example, what does the NAS 12 to NAS 7 mean? In a barrel which contains 210 liters of oil, it means to move from NAS 12 to NAS 6, you have to remove 2.048 billion particles from the oil through filtration. This is approximately 2 times India's population. So you can just think about it. Like I said, you also have got ISO 4406 standard, which has a different system, but the fundamentals are more or less same. It can be correlated to the NAS standard. This is the equipment used for measuring the NAS standard. It has the ISO mode and the NAS mode. This is the NAS filtration system we employ in our plants to get the super clean oils, so that the hydraulic oils which are shipped to our customers are super clean. In some cases, in certain OEMs, we have worked together to set up the equipments in their factory also. Another trend is having a multigrade hydraulic oil. That is, you boost the viscosity index of the hydraulic oil so that it operates at the point of peak efficiency. You can see that the efficiency of a hydraulic system is dependent on two factors: volumetric efficiency of the pump and the mechanical efficiency. At the midpoint, you have got the point of maximum efficiency, which is obtained by using a multigrade hydraulic fluid or a fluid which is having a high viscosity index. Today, the trend is that you can optimize the fluid for certain OEMs depending upon his pumps and motors, so that the hydraulic fluid gives you peak efficiency and there is savings in the fuel consumption. Then this is our latest offering. We have got Enclo Synthetic, which is a synthetic hydraulic oil, which is made from synthetic base stocks. It features zinc-free technology, and it is ashless. It is absolutely, it does not harm the environment. It is, you can say, eco-friendly oil. It is meeting all the latest standards of all the OEMs like Jack Ma's OEM requirements of Denison and Eaton and Rexroth. We also have a biodegradable fire-resistant hydraulic oil, which is also a high-efficiency hydraulic fluid. Apart from that, we also help the customers in doing the condition monitoring of the oil. It is something like I said again, you go to a doctor, you go to the pathology lab for a blood test. This sort of thing we do for our customers and OEMs. We do the testing of the oil. We say what is the viscosity, what is the flash point, what is the contamination level, what is the oxidation level, and we recommend the various steps to be taken. These are just view of some of the drain intervals some of the OEMs are following. I believe some of them have even gone for higher drain intervals beyond 5,000, 6,000 hours. Many OEMs are going in for increase in drain periods to lower the cost and increase the end value to the customers. Thank you. Thanks a lot.